This is a video for AQA Further Pure, First Order Differential Equations, 1.3, Separation of Variables. Some linear first order differential equations can be written as dy by dx is equal to some function of x and y. If we look at this equation, it's first order because we've only got dy by dx. We haven't got the second derivative, for instance, or any higher derivatives, so we won't see those. And we haven't got a power of dy by dx, so you wouldn't see something like dy by dx squared, for instance. Differential equations including those would either not be first order or not be linear. If the right-hand side can be written as the product of two separate functions, gx and hy, then the equation can be solved using a method known as separating the variables. If we look at this first equation, I can rewrite it as dy by dx is equal to x squared plus 2x times y. And so I've got a function involving x only and a function involving y only, and they're multiplied together. So this one is in the correct format for using separating the variables. This one cannot be rewritten as a product of two functions, one involving only x and one involving only y, and neither can this one. So neither of these can be solved using separating the variables. Okay, so let's separate the variables. The first thing to do is to write it as a product, so that's going to be 1 over x times 1 over y. And then I'm going to multiply through by y to give me that y dy by dx is equal to 1 over x. Integrating both sides, I'm going to get the integral of y dy by dx is equal to the integral of 1 over x dx. And I've integrated both sides with respect to x. This here simplifies down to just the integral of y dy. And that is 1 over x dx. We'll do the integration. We get a half y squared is equal to the log of mod x plus c. Now if I multiply through by 2, I'm going to get that y squared is equal to twice log of mod x plus c is just an arbitrary constant, so I'm going to write a new constant k, thinking about k as being twice c. And now I can square root both sides, so I get finally that y is equal to square root of 2 log mod x plus k. And there's that work written up for you so you can read it more easily. Separated the variables, come down to my integrals on both sides, and then follow the integral through to get down to my final result. So let's have a look at the general case then. If we've got a differential equation that can be written as dy by dx is some function of x times some function of y, what can I do with that? Dividing through by gy, I'm going to get 1 over gy dy by dx is equal to fx. Integrate both sides, and I'm going to get 1 over gy dy by dx dx is equal to the integral of fx dx. And this I already know will simplify down to give me just a dy there, so I've got the integral of 1 over gy dy is equal to the integral of fx dx. There's that written up again so that you can follow it through maybe a little bit more easily. And there's our final result. And this works for all differential equations of this type. The next video is 1.4, applying the separation of variables method.